Hello everyone. So this lesson is about the squeeze theorem. So we were not able to discuss this when we discuss limits. This actually is the continuation on how we find the limit of some trigonometric functions. So in here, we start first with the discussion of the squeeze principle. So we say here that the squeeze principle is used on limit problems where the usual algebraic methods like factoring, conjugation, algebraic manipulation, like rationalization, are ineffective. However, it requires to squeeze the problem in between two other simpler functions whose limits are easily computable and equal. However, using the squeeze principle requires accurate analysis, algebra skills, and careful use of inequalities. The method of squeezing is used to prove that f of x is L as x approaches c by trapping or squeezing f between two functions g and h, whose limits as x approaches c are known with certainty to be L. Likewise, the theorems and limits are applied. Hold on. We just have to erase this one. Okay. So here is the how we apply the squeeze principle. So let us assume that the functions f, g, and h satisfies this inequality, this one here, and that the limit of g of x as x approaches a is L equal to the limit of h of x as x approaches a. Then if this happens, then the limit of f of x as x approaches a is equal to L. So we can find the limit of g of x first and the limit of h of x. If they are both equal to L, then the limit of f of x as x approaches a is L. So look at this example here. So given this one, if we use the principle that if g of x is less than or equal to f of x, and that it is also less than or equal to h of x, then let us let f of x be equal to cosine of 1 over x. Okay, now you know that from trigonometry, you learned how to draw the graph of cosine. Hold on, let's change this one. You know how to draw the graph of cosine of x, right? So say for example, the trend of the graph for cosine goes this way. So this is y, this is x. So we divide, say this is our, okay, we divide one region or one revolution into four equal parts, so that if say we have if from here, if y is equal to cosine of 1 over x, we know that the amplitude is 1. So let's say this is positive 1 and this is negative 1. Y equals cosine x. The graph goes this way. So we start with the maximum, then we go down to 0, then minimum, go back to 0, and then you go to maximum. So the trend of the graph goes this way. Okay, so that if we let f of x be equal to cosine of 1 over x, so we have your cosine of 1 over x, and that it's because look, this is actually our amplitude and this one here. So cosine of x cosine of 1 over x is greater than or equal to negative 1 but less than or equal to 1. Okay, so this comes from the graph. Now if we multiply all the terms by x squared, this becomes negative x squared is less than or equal to x squared cosine of 1 over x less than or equal to positive x squared. So therefore, by the squeeze theorem, this will be your g of x, this is your h of x, and this is your f of x. So we can find the, let's put it here, we can find the limit of, hold on, we solve for the limit of negative x squared as x approaches 0, and that will be 0 when you substitute 0 for x, and the limit of x squared as x approaches 0 is also 0. Okay, then that's for our for the limit of the left side and the right side of the inequality. So therefore, from the squeeze theorem principle, if you want to find the limit of g of x as x approaches 0, that will also be 0, and the limit of h of x as x approaches 0 is also 0. So since both the limit of g of x and h of x is 0, then we have, therefore we say that the limit of x squared cosine of 1 over x as x approaches 0 is 0. Alright? So again, because negative x squared, hold on, because this one here is your g of x. You might get confused on this one. This is actually your g of x, right? And then this one here is your h of x. Alright? So therefore, by the squeeze theorem, we get the limit of x squared cosine of 1 over x is equal to 0. Now, besides using this principle, we also have, from the squeeze principle, from the discussion, or from this squeeze principle, we get two different theorems. So the first theorem is this one, and we have another theorem here. Okay, so if you're going to look at the graph of the function here, the graph of sine x over x is this one here. So that if you're going to look at the graph, if you want to find the limit of the function, the limit of sine of x over x as x approaches 0 coming from the right is 1. It's this one here. And coming from the left, it's also 1. Okay, then if you're going to look at the graph of this one, because the limit of 1 minus cosine x over x as x approaches 0 is 0. So if you're going to look at the graph of this function, again, coming from the right, the limit is 0. Coming from the left, the limit is 0. So the two-sided limit exists. And we just simply use these two theorems in evaluating limits, evaluating some trigonometric limits. Okay, so let's look at the first example here. We're asked to find the limit of tangent of x over x as x approaches 0. Now, we want to use either this first theorem or the second theorem here. Now, to use let's check if we can use or we can apply the limit of sine of x over x as x approaches 0 equals 1 in this problem here. So let's write the solution for number 1. We're asked to solve for the limit of tangent of x over x as x approaches 0. So we have to find a way of expressing how we could arrive at sine x over x. Now you know that tangent can be written as sine of x over cosine of x over x. And we can write this as sine of x over cosine x times what? This is division. This is division. So if we write it in the, or if we simplify, if we do division, if we perform division, you have to divide the numerator by, or you have to multiply the numerator by the reciprocal of the denominator, which is 1 over x. Okay? So we want to have sine x over x. So we can combine these two. Alright? so that you can change this into the form limit of sine of x over x times 1 over cosine of x as x approaches 0. And by our theorems on limit, the limit of the product, you have the product here, the limit of the product of this and this one can be written as what? The limit of the limit of the product can be written as the product of the limit. So you could write it as the limit of sine x over x as x approaches 0 multiplied by the limit of 1 over cosine of x as x approaches 0. And this can be, what is the limit of sine of x over x as x approaches 0? From here, it means that this will be equal to 1. Then we multiply that by the limit of 1 over cosine x. So we substitute here 0. So 1 over cosine 0. And cosine of 0 is 1. So the result here is 1. So the limit is equal to 1. Okay, so we have to look for, or we have to simplify or manage the equation so that we can use, or we can change it into either this form or this form here, so that we could apply this theorem. Alright. Okay, so let's go over the next number. So for number 2, we're asked to solve for the limit of sine of 3x over sine of 5x as x approaches 0 also. So again, we need to do algebraic manipulation to change this into a form wherein we could apply the two theorems shown here. Okay, so for this kind of problem, we need to have sine over x. So what we do is we could write this, we could multiply this by 3x over 3x. And then in the denominator, you have sine of 5x, we can multiply this by 5x over 5x. So we did not actually change the problem, because 3x and 3x will cancel out, 5x and 5x will cancel out. So our objective here is we want to produce this. Kailangan magkaroon tayo nito. Okay? So therefore, if we simplify, we group sine 3x over 3x. So we could write this as sine of 3x. Hold on. Yeah. Let's change. It should be in the numerator. So we should have here sine of 3x over 3x. And we multiply by 3x, right? The denominator can be written as sine of 5x over 5x times 5x. Okay, so then we could write this as what? We can cancel this out. Alright? So that we could write this as the limit of 3 over 5, which is a constant, multiplied by sine of 3x over 3x, then is sine of 5x over 5x as x approaches 0. And then we could we can first write, we could take out 3 over 5, and then you have the limit of sine of 3x over 3x over sine of 5x as x approaches 0. And then the limit, because you have here the quotient, right? The quotient of this and this one. So we could write this as 3 over 5 times the limit of the quotient is the quotient of the limit. So you could write this as sine of 3x over 3x as x approaches 0 over the limit of sine of 5x over 5x as x approaches 0. And so that this becomes what? Now take note that this follows this form now. From here, diba, this is the principal. So this one here, we can use this now. Because we could write, take note that if we have to find the limit of sine of 3x over 3x as x approaches 0, look, it gives you, that will give you 1. So why is it 1? This, take note that this and this one here must be the same, and it's already here. You can see here that they are now the same. So hold on, you have, okay, this and this one are the same. So therefore the limit is equal to 3 over 5 times the numerator is equal to what? From this one here, this is equal to 1. That's our principal here. That is equal to 1. Okay, from this one here. Alright? So, this is now equal to what? The denominator is now equal to, okay, this is 1, right? Hold on. Let's change this. This limit here is equal to 1. And the same thing happens here. This limit, because 5x here in the numerator and 5x in the denominator. So that is also 1. So the result is 3 over 5. Okay. So that's number 3. Now, that's number 2. Let's do number 3. So for number 3, we have the limit of sine of 2x over x as x approaches 0. So again, you could not use the theorem because the numerator is 2x, the denominator is x. But by the double angle formula, sine 2x can be written as 2 sine x cosine x over x. Okay, and then we can group these two together so that we could apply again this theorem that the limit of sine x over x as x approaches 0 is 1. Okay, so this now is equal to what? You could write this as the limit of, we could put 2 in front. Let's try. We can first take out 2. Then you have the limit of sine x over x times cosine of x. Okay, so as x approaches 0. So now we can write this as 2 times what? The limit of the product is the product of the limit. So you could write this as the limit of sine of x over x as x approaches 0 multiplied by the limit of cosine of x as x approaches 0. And that you have here now 2. And this one is equal to 1. Multiplied by cosine of 0 is 1. Cosine, because you substitute here 0. Cosine 0 is 1. So we get here 2 times 1. The limit is 2. Okay. Alright, so the next that we have for number 4 is for us to find the limit of, okay, limit of 2 minus cosine 3x minus cosine 4x over x as x approaches 0. So because you have your cosine, we have to try if we can change it into 1 minus cosine x over x. so that if you approach 0, that will give you 0. Okay, so now look at this one. We can rewrite this so that we have the limit of, hold on, actually 2 can be written as, these 2 here can be written as 1 plus 1, and then minus cosine 3x minus cosine 4x over x. Okay, so if we, because our objective is to have 1 minus cosine, so in here we can rewrite this as the limit of 1 minus cosine 3x, right, plus 1 minus cosine 4x over x as x approaches 0. And then we can rewrite this as the limit of 1 minus cosine 3x over x plus 1 minus cosine 4x over x. So if you're going to check, if you're going to simplify this one, it's the same as this one. Okay, so as x approaches 0. Now the limit of the sum is the sum of the limit. So you have the limit of 1 minus cosine 3x over x as x approaches 0 plus the limit of 1 as x approaches 0. Okay, and this gives you what? Now take note, you have 3x, but the problem or the principle here is what? You can see here that it should be what? You should have the same, hold on, let me erase this. You should have the same denominator. So if this is x, hold on, if this is x, this must also be x. So we could not apply it yet here because the numerator and the denominator have different coefficients. Okay, so for us to have, we have to multiply this by 3, right, so that we could apply the theorem. But when we multiply by 3, when we divide by 3, you have to multiply also by 3, so that we actually multiply this by 1. Now this one, you multiply this by 4, so you have to multiply this also by 4. So that if we're going to simplify, you could write here 3 times the limit of 1 minus cosine 3x over 3 as x approaches 0 plus 4 limit of 1 minus cosine of 4x over 4x as x approaches 0. Okay, what's this limit? Sorry, hold on, it's not 3, hold on, there is something wrong. We should have 3x. This must also be 4x. Alright, so what is this limit now? That gives you, what's the limit as x approaches 0? It should give you 0. So therefore, this is equal to what? Equal to 3 times 0 plus 4. This will also be what? 0. So the result is 0. Okay, so you have to know how to do algebraic manipulation to change the equation, or to change so that we can apply the 2 theorems mentioned here. Okay, and take note that the numerator, the coefficient, the numerator here, if the numerator has 3x here in the, as, or the cosine of 3x, the denominator must also be 3x. If you have here 4x, the denominator must also be 4x. Alright, so that ends this lesson on the squeeze theorem. Bye bye.